question 3. And the question doesn't even say that it's actually looking for an IRR. It just asks what the break-even. In the second part of the question, it asks for the break-even rate. The first part just says, should the cemetery take the business? So let's just set it up first, and then we'll go from there. So the cemetery project will provide a net cash inflow of $415 for the firm during the first year, and the cash flows are projected to grow at a rate of 3.8% per year forever. The initial investment is $4.7 million. Okay, so this is going to be a growing annuity. And the reason that I know this is because we get a cash flow in the first year and it grows forever at a rate of 3.8%. I'm sorry, it's a growing perpetuity. So I can delete this formula that I copied from the internet a minute ago to show you. So let me just draw the timeline and kind of show you. And this would go on forever, but the cash flow in the first year is going to be $415,000. Now, this is not a good way to solve this, so I don't know that you should necessarily copy what I'm doing, but I just want to show you the first year is minus 4.7 million. And let's put that in the same, nope. Formulas, page layout, format, that's what I'm looking for, cells. Currency, negative, 0 decimal places. Okay, now it's pretty. All right, so this is our outflow the first year, and these are the cash flows, and they're going to go on forever. This is a perpetuity equation. So if you were actually drawing this on your paper, there would be a timeline. It would go all the way out to t, and it would be, I'm sorry, not t, it would go to infinity. There would be an arrow that just pointed to the right. Since we don't have to do that, we can just use the perpetuity equation. And in this case, we need C, we need R, and we need G. And that's all we need, because the equation for growing perpetuity, let me put growing here, is going to be C over R minus G. So C is going to be this. R, based on the problem, is going to be 11%, so 0.11. G is going to be 0.038. And the present value of this perpetuity is going to be let me put this in a decent format. Where's the format? There. Oh, dang it. Paste special formatting. Okay, so this present value is the same thing as all of these cash flows forever and ever and ever and ever and ever added up. And to get the NPV of this project, we can delete these. Oops. We can pretend that these don't exist. I'm going to make them white just so we don't pay attention to them. And all we have to do to get the net present value of the cemetery is to add up these things, not the 0, but the 4.7 million. So this is our initial investment, PV of cash flows. So the initial investment is 1.063 million. We should get that here, yes. And that is the amount that it's positive. We would take the project, makes total sense. Okay, so the next question is, at what constant growth rate would the company break even if it still required a return of 11%? So when you see that, and let me add a little line here so it's clear that we did some addition. When you see that, what he's asking for is the growth rate. So what G, at what constant growth rate would the company break even? Break even means the NPV is going to be set to 0. So what are we going to do here? We're going to goal seek. We're going to set the NPV equal to 0 by changing the growth rate. The answer is going to be 2.17%. And there it is, 2.17%. So that's the idea there is if the cash flows didn't grow very fast, then at some point below 2.17%, it wouldn't be worth it for us to do the $4.7 million to invest in the cemetery. Above 2%, if they grow more, which is kind of weird to think about for a cemetery, but if more people end up dying every year, then we'll be fine with the cash flows and we'll make a positive NPV. That's kind of a dark problem. But anyway, that's the solution.